So for tens of years since the beginning of the space age, we had either one spacecraft, at best two spacecraft following each other. And we are in a 3D environment, and we have one point of measurement. And if you do basic physics, you realize that you need at least 4 points of measurements. Otherwise, you have some hypotheses you can never test.
The specific thing about cluster that's different to anything that came before, and let's make a comparison to, say, weather buoys or a buoy in the ocean. If you have 1 point in the middle of the ocean, you've got 1 point in the middle of the ocean. You don't know what something's happening 4,000 kilometers away. There could be a storm and it's sunlight where this one is. This is similar to what we see in space. There are these differences in location. We also have phenomena like waves, turbulence. All of these things have structure on different scales.
These are waves that you see almost everywhere, where you have a flow or wind flowing, for instance, on the water, is forming waves. And what we've seen with cluster, we had seen that before cluster, that we had this wave. But with cluster, for the first time, we have seen that this wave, when they approach, for instance, to the shore, or when they develop along the flank of the magnetosphere, they develop as vortices. So it's very similar to the wave and a surfer. When the wave approaches to the shore, it's starting to rolling up and forming these tubes that surfer like very much. And this is exactly what we see with cluster. We could see only that it was a rolling up of the wave because of the 4 spacecraft.
We could set the size of cluster to investigate those structures, and this had never been done before. We could assume it with 1 spacecraft or 2, but with 4, it's the first time you can get an idea of the 3D structure that's going on and passing you by.